Hi folks, we're going to take a look at yet another pretty classic analytic geometry problem, and that's analyzing shapes. In this case here, we're analyzing a quadrilateral, and they want us to show that this quadrilateral is indeed a parallelogram. Okay, and then they're asking us to confirm one of the properties of parallelograms. Okay, let's start with the first problem. So one thing you want to keep in mind is that when they give you a shape, okay, the order in which they give the letters is not by accident. Okay, the order in which they give the letters is the order in which you're connecting the points. Okay, so if I have, point R is then connected to point S, which is then connected to point T, which is then connected to point U, and then of course the last two are also connected. Now notice here I sort of drew it like a parallelogram because they told me that it should be a parallelogram. I wouldn't draw it quite like this if I didn't know what type of shape it was. Okay. All right. Again, you'll notice I'm drawing this diagram, no Cartesian plane, because I'm just using the diagram as a guide. All right. So first question is, what's a parallelogram? In other words, what do I have to show that this is indeed a parallelogram? Well, it's in the name. Opposite sides are parallel. So this is where we remember, well, how do we deal with, determining that two line segments are parallel? Well, it means their slopes have to be the same. So this first part of the question is just about determining all the slopes and seeing if opposite slopes are indeed parallel to each other. Okay, so let's start with these two sides that are opposite to each other. And when you're finding things like slopes, I'm finding four different slopes. I don't want to just use M every single time, so the person looking at this can't distinguish which one you're talking about. And I don't necessarily want to use 1, 2, 3, 4. I could if I label all these sides 1, 2, 3, 4. What I'm going to use instead is I'm going to use the 2 points that's joining those line segments. So I'll call this the slope of RS. Okay, so I don't need to indicate anything else on my diagram. It's already there. So how do we find the slope of a line? Well, it's the difference in the y's divided by the difference in the x's. So let's work with RS, so 3 minus 1 divided by 5 minus negative 5, the difference in the x's. Okay, so let's simplify this. What do we have? 3 minus 1 is 2. This becomes 5 plus 5 is 10. So we have 1 over 5. So there's the slope of RS. Let's now find the slope of the side that's opposite. How do I know it's opposite? Well, that's where the diagram comes in handy. The fact that it's not precise doesn't make a difference. I can tell that the opposite side has to be TU. Okay, so let's find that slope. So negative 3 minus negative 1. Difference in the y's and difference in the x's is going to be negative 8 minus 2. And so what do we have? We have negative 3 plus 1, which becomes negative 2. And negative 8 minus 2 is negative 10. And when I simplify, this is still equal to 1 over 5. Okay, so we see that these two slopes are indeed equal. So opposite side, these two opposite sides are parallel. All right, so now let's find the slopes of the other two opposite sides. So let's do ST. So slope of ST here, so negative 1 minus 3 over 2 minus 5. Okay, so this becomes negative 4 over 2 minus 5, negative 3, so 4 over 3. And now let's find the slope of its opposite side, which is going to be RU. Okay, so RU, so we have negative 3 minus 1 over negative 8 minus negative 5. Negative 8 minus negative 5. And so here we have negative 4 in the numerator, and we have negative 8 plus 5, negative 3 in the denominator. And so yet again, we have 4 over 3. Okay, so since these two slopes are also parallel, so here we can say, let's put a concluding statement. We can say RSTU is a parallelogram since opposite sides are parallel. Okay. Good. So as we talked about, these shapes, once you know what shape it is, they have certain properties. So as we know, opposite sides of parallelograms should have equal length. So if that's what they were asking me to do, I'd just find the distances or the lengths of all these line segments using the distance formula to show that they were indeed of equal length when it came to opposite sides. All right, so that's not what they're asking us to show. They're asking us to show that the diagonals of the parallelogram bisect each other. So bisect each other basically means cut each other in half. Okay, so if I draw the two diagonals, so RT and SU, and even looking at my not great diagram, it doesn't seem outrageous that this line cuts SU in half and this line cuts RT in half. So the question is how are we going to show that? And I actually gave you a hint here. I guess I should have let you figure that out. But if this line cuts SU in half and the other way around, it means their point of intersection must be the midpoint of each line. So this point, because it's the same length on either side, is the midpoint of RT, and it also needs to be the midpoint of SU. So this is where we can now use the midpoint formula to determine whether they indeed bisect each other. Okay, and so that's what I'm going to do. So the first thing I'm going to do is find the midpoint of, I'll start with RT. Okay, and our midpoint formula is, well, you can think of it as it's the average of the x values and the average of the y values. Okay, so let's find the average of the x values of RT. So it's -5 plus 2 divided by 2, since there's only two numbers. And then let's look at the y values, 1 plus -1 divided by 2. Okay, and we see here that we've got -5 plus 2, so -3 over 2. And this is going to be 1 minus 1. 0 over 2 is just 0. And so now let's find the midpoint of SU. And if it's the exact same midpoint, then we know that they bisect each other. Okay, so what are we doing? SU here. So 5 plus -8 over 2. And then here we've got 3 plus -3 over 2. And when we calculate that, it's looking pretty good because 5 minus 8 is -3 over 2, and 3 plus -3 is 0, divided by 2 is just 0. Okay, so here we can say, since the diagonals share the same midpoint, okay, we can say that they bisect each other. Okay, so they cut each other in half. All right, so let's do a recap. Step number 1, as with the last question I did, I draw a diagram. I don't necessarily make an effort to be accurate, but because I'm just using it as a guide. Secondly is to use some basic knowledge. So I do expect people to know what makes a parallelogram a parallelogram. In this case here, opposite sides are parallel. And so I just use what it takes to show that two things are parallel, which is that the slopes must be equal. Okay, in the second part, I reasoned out that if I showed that the two lines, the two diagonals shared the same midpoint, that they would be cutting each other in half. Okay, now just as another thing, let's take a look. Is this parallelogram also, say, a rectangle? How could I tell? Well, again, rectangles have opposite sides that are parallel, but they also meet at right angles. And if we notice here, look at adjacent sides, so RS and ST, look at those two slopes. Are they negative versus reciprocals of each other? No. So I could also, continue on and say, hey, I know that it's a parallelogram, but not a rectangle. Okay, that's it for this one.